Taking a look at this, making sure that you're looking through this information. So when we look at it, we're still talking about the averages. So today we're going to talk about measures of center and the measures of the spread of our data. So when we talk about center, a lot of times we might use medians. That's what we did yesterday when we were doing our box and whisker plot, the exact middle of our data. But if we're comparing these, this middle of this information is very different, like numbers for our information. Even though this in the middle, here our spread isn't much, where here our spread on the top one is very big. So when we are looking at those, that's one of the things. So measures of center, the vocabulary, which we've been doing the last couple of days as we talked about it. Mean is the average, add them all up, divide. We have been finding the average of our median when it's in between two numbers because we added 5 and 7 and divide by 2. Most of you usually knew what that was. So the median's the middle. Always has to be a numeric order, and then mode is the most often. Now, you could have no mode with data, or you can have more than one. So if I would have had these 4 13s, and then I would have had 4 14s, and then 18, I would have 2 modes, 13 and 14. Both have 4, so that's possible to have more than one. This part, again, you want to read through this very carefully about what the mean is. When we typically use it, what are the pros and cons? I will be asking you about these pros and cons of mean, median, and mode when we take our test. So they also talk about an outlier. The question is, what is an outlier? An outlier is for when you look at our data, it's one of the points that doesn't fit in within a certain range of numbers, okay? So you will see that outlier come up. Measures of spread are different than measure than center. Measure of center was our mean, median, mode. Those were our center. Measure of the spread is called our measures of variation. Today we're going to do standard deviation, which is a type of measure of our spread. It helps us describe our data. The two most common ones are range, and then we have been working inside that box. That's called our interquartile range. So when we are looking from quartile 1 to quartile 3, that's called the interquartile range. So when you know the range, you're taking the largest minus the smallest. Interquartile range just means you're taking quartile 3 and subtracting quartile 1. Okay? So a lot of vocab in that first one. Please make sure you go back, take a look at it. We want to get to this, but we more importantly want to get over to page 15 in your notes. If you don't have a calculator, you need one. So if we are looking at this, could we easily tell the range for each of these two? Could we easily tell? So we're going to take and subtract them. So for Miami, it looks like it's about 8.5 down to, if we were subtracting that, we might say Miami's at about 7, New Orleans about 4. Does that make sense to you? We are looking at 8.5 and we're subtracting 1.5, right? So 8.5 minus 1.5 would give us about 7. If we look at New Orleans, we're going from 7 to about 3, so about 4. Okay, you don't have to be exact on the decimals because we don't know exactly if it's 8.5 or 8.6. Interquartile range. So please write now in your notes. You don't need your computer at all, so you can shut your computers. Don't need them. I just need for you, and calculators are up in front if you need a calculator. I need you to now find your interquartile range. So interquartile range, that means we're going to take and subtract quartile 3, right? So quartile 3 minus quartile 1. And same thing here, quartile 3 minus quartile 1. So if we are doing those subtractions, for Miami between 4.5 and 5, and for New Orleans about 1, right? We're going from 6 to 5. Okay, so they approximated. What if you had 1.1? No problem. If you had 0.9, no problem. That would be correct as we look at this data. So which measure of the measures above would be more affected by an outlier? So an outlier is that one number that's way off, and if we are looking at this, our range is going to be more affected than our interquartile range. Because the range is affected because if I have 12 inches up here Or if I had this one in New Orleans, I have these, and then I have one that's way up here, it's going to affect the range, not the interquartile range. So that last question that we are filling in, what do ranges tell us about the data, and to be detailed, this would be kind of what I am looking at for you to fill in. The average monthly rainfall when we are looking at this in New Orleans is much more consistent, right? Why is New Orleans more consistent? Because we're looking at our range is a smaller number, right? So we get about the same, whereas Miami has much higher and lower amounts of rainfall. So theirs is much more spread out when we are taking a look. What is the standard deviation? So another common measure of spread is standard deviation. It measures how far from average the data point varies from the mean. So this is our definition. How far, this measures how far the average data point, which means we have to find the mean, varies from the mean. So we're looking at the change. So they analyzed some data. Here's the temperatures for the first 8 days in August during 1 year. They give us those temperatures. They've calculated the mean. How do you calculate the mean? You add them all together and you would divide by 8, okay? And the standard deviation. We're going to calculate standard deviation in a minute. It tells us is 4.7. What does this mean? How do you understand this? That one standard deviation, we're always going to put our mean in the middle, okay? So the mean comes out to be exactly in the middle of our data. And then you're going to move whatever that standard deviation, so it's 4.7 degrees above and below 91 degrees, that average, is one standard deviation. You're just taking 91.5, adding 4.7 to get 96.2. You're taking 91.5, you're subtracting 4.7, that gives you 86.8. So the area of the number in that pink region represents one standard deviation from the mean. Generally, in a normal distribution, 68% of our data will fall in this range. In this case, 5 out of our 8 data values are in that range, and that is about 68% if we are, is a bell-shaped graph. So I always have students ask me, Mrs. Thompson, are you going to grade on a bell-shaped curve? And I want you to look at when we get to this, why you would never really want a teacher to grade that way. Because what happens in a bell-shaped curve is that the majority of people get C's. And then you get a few people with B's and A's, and then a few people with C's and D's. You do not generally would want that to be graded on a, that type of a bell-shaped curve. There are professors at the college level, and sometimes where you would have someone grade that way. So, standard deviation. This is the website. I put this on the daily planner also. Standard deviation just measures the spread of a number. So this is the website that I have. Usually they use this Greek symbol, which is sigma, for standard deviation. The formula is easy. You're going to take the square root. You know how to take the square root, right? Square root of the variance. So we're going to look at doing this today, and that's why I wanted to get to this part of our notes rather than the later part. So it says variance is defined as the average of the square differences. We're going to do this with just 5 numbers in our data in our notes from the mean. So to calculate the variance, first thing you always have to find is the mean. That's why I said you need calculators. Then for each number, you're going to subtract the mean and square the result. We're going to do this when we do those tables. That's what that table on the top of page 15, when you're looking at that table, they're subtracting those and finding that, and then they're squaring it, and then at the end, we're going to take the square root. So, well, why are we looking at finding the square of it? So here's an example with some dogs. You and your friends measure the heights of dogs in millimeters. So you go to the dog park and you just decide, hey, I'm going to measure all these dogs. So you measure them. You got 600 millimeters, right? 470, 170. You measure the dogs. You find the mean. To find the mean, we're going to add their heights, divide by 5, because we had 5 dogs. We find that the average, or the mean, is 394, in this case, millimeters. So this green line here is the average height, right? Then it says we need to calculate the difference from the dog's height to the mean. So how much different is the height from their back? So this one was up 206, up 76, down negative 224 for that little dachshund, right? This one is going If we are looking up 36, not much, and down negative 94. The reason we are going to find and we're going to square those numbers is because when we look at that finding the average, that variance is usually going to be a positive number. So we get this. So the variance is 21,704. The standard deviation is when we take the square root of that, which is 147. This means within, from the average, using the standard deviation, we have a standard way of knowing what is normal and what is extra large or an extra small dog. If you're within that 68% range, you're probably normal for that data. If you're outside of that, obviously you are getting to be, so Rottweilers are taller dogs, Dachshunds quite a bit shorter. They are going to fall out of that normal range, okay? So it says, but there is a small change in the data. So say we change one piece of information. For example, we have 5 dogs that we are looking at, but then we take a look at a bigger population. What's going to happen is that our numbers, when we calculate that variance, is going to change. So just to be careful when you're looking at that. So this website, then it shows these ugly formulas. If you look on page 15, right, in your notes on the top of that, do you see some of those ugly formulas that we're going to be looking at? They're not that bad once you look at what they mean. But at first looking at them, they're like, oh my gosh, kind of a little scary. And they kind of show, this is how they find those differences, so as you are looking at that. But right now, we want to go on top of page 15 as you look at your notes. So what they did, just some information, the Greek symbol sigma, the Greek letter sigma is what we're going to use, that represents when we talk about standard deviation. When you see that big like capital E, that's called our summation, so that's the capital sigma. Okay, so this is our lowercase if we're looking at it in the capital one. X stands for our data. The X with a line over it is the mean. Okay, so when you have that X with a line over the top, that means the mean. So you don't have to write out the word mean. Anytime you put X with that line over the top, we know that that means the average of it. And then N is how many numbers we are looking at. So they first calculated the mean. So we had all this set of data. This was my set 1. I give you this data. So down below, you're going to notice that I give you 102, 198, 100. We're going to find that average first. How do you do that? You add these numbers and divide by 5. It came out to be 15. So the average of that was 15. We then are going to take 12.6 and minus 15. 12.6 minus 15 gives us negative 2.4. Then we take 12.6, 15.1 minus 15.1, 11.2 minus 15. So we get those numbers. Then to get this next column, what you're going to do is you're going to square. So you square whatever this answer is, that's what these numbers are. And then you just add them all up. Okay, so we had to take negative 2.4 and square it, you get 5.76, 0.1 squared, 0.01. Negative 3.8, when you square a negative, because negative times negative is positive, none of these values should ever come out negative, right? We're going to add those together. That gives us a 7. That's what this means. The sum, you're adding all of these, and then you're dividing it by n, okay? You divide by the 5 numbers. So we added those up, divided by 5, we get this. To find our standard deviation, we are then going to take the square root as our last step, okay? So we're going to actually do this. So the nice thing is, you do not have to memorize this formula. Isn't that nice? But you need to know how to use it, and we are really going to be putting it in spreadsheets and using technology instead of ever doing this by hand. But you do need to do at least once by hand. So what we are going to do is we're going to divide the room in half. And this half of the room, you're going to take, so people over by the window through right here, you're going to do this first half. Okay, so my window people over to this half. You are going to start by finding the average of this. You guys are going to do it for this set of data, okay? So the people that are kind of sitting by the door, this half of the room. So you're going to add the 6 numbers, right? And then divide by 6. Here you're going to add the 6 numbers and divide by 6. So everyone by the window, hopefully you got 100, right? Okay? So we put that 100 down in every single one of them. People over by the door, what'd you guys get?
95.8.
95.8 we're going to go with. Okay, 95.8. So, as you are looking in your notes, please fill the 196. And you have a calculator in front of you. So, when you put this, when you square this, you're taking the negative 14 times negative 14. So, 1 and 100. So what we now need to do is we need to add this column. So add that on your calculator, please. We're going to put that number right over here because we have to divide it by 6. Okay? So 100 plus 1 plus 196 plus 9 plus 4 plus 4 gives us 314 divided by 6. I know, negative. Should have no negatives because everything was positive. Because you square a negative number and it's positive. Negative times a negative is always positive. And if you are messing up on that, use a parenthesis. Okay? Square root of 52.3. So, square root, you might have to go above the x squared. Okay? So for a lot of you, the x squared button above it is your square root. You should get 7.23. Okay?
Oh, we did what?
You take the square root. You're trying to find the number times itself that gives you 52.3.
So wait, so how do we
Square root.
52.3?
We're going to keep squaring. Negative 6.8 squared does come out to be 24, 17.64. Add these up. Now, you have to add this whole column on your calculator, right? And you're going to divide it by 6. Now, this is why we're going to use technology after this, because make sure if you put them all in your calculator that you hit equal after the 1.44 and then hit divide by 6, right? If you just divide the last number by 6, you're only dividing this by 6. So when you add these all up, make sure you hit equal, then divide by 6, or put it in a parenthesis, that whole thing. We should have got, anyone get it yet? 4.81. Yeah, let's go 23.1. About how we use the standard deviation. The average is here. One standard deviation, I'm going to take 95.8 and I'm going to add on 4.8. What would I get? How far away is this data point going to be? 95.8 plus 4.8 gives us 100.6. Now take 95.8 and subtract 4.8. 91. So this is telling me that for this data, 68% of this data has to be within this range, which is one standard deviation away from my mean. If I go 2 standard deviations away, I have more data points there. Tomorrow, on Monday, we're going to talk about that also. 2 standard deviations, I'm going to take this 100.6 and I'm going to add on another standard deviation. 4.8. Where would be my new point if I had for that second standard deviation away? So I'm going to have 105.3. Okay. If I take 91 and subtract 4.8, I'm down at 85 point upstairs. Okay. So what we want to take a look at. Turn to your homework. You need to make that table. X. So that exact table. You're going to put the X down. So if you turn and look at page 15 of your notes, this is how you have to start to find this. You've got to find X. The next page is, the next column is going to be the mean. The next column after that you are looking at is going to be where you subtract those. That's what we did. X minus the average. Okay. The next column that you are going to be looking at is when you square that, x minus the average squared. So put your 5 numbers to the side. So we have 6, right? We have 12, 5, 11, 8.
Yeah, it's at 9. Oh, she wrote 9.
6,
She said
12, 6, 12, 9, 11, 8. Okay? You are then, so this is that next column where you find the sum, right?
Can you put them in order if you want?
Sure.
If you like.
Divided by 5, right? That's still not your standard deviation, right? The standard deviation is when you take this number and you take the square root of it. That's going to be our sigma, right? That number. So when you look at the back, can you find the mean? That's the first question, right? The mean. So you might write over here, the mean is equal to. Then you're going to tell me the median. That's especially when you want them in order, right? You do that without standard deviation, right? Just same thing as we did today. Where is the middle, right? You're asked for the mode. Is there one that occurs the most often?
No mode.
No mode. You don't say the mode is 0. If there's nothing that occurs the most often, there's just no mode. You are also asked to find the range, the standard deviation. That's the only one that has a lot of work.
Yeah, that's
Right? So I just want you to be aware that you only have to find the standard deviation in question number 1, and that's the only one calculating it. And usually from now on, I'm going to have you use technology. But I do need you to practice it and see that this comes out correctly. I want you to look down at question number 3 right now. Question 3. So it says this table shows a basketball player scores in 5 games. How many points must the player score in the next game, which we don't know how many they're going to score, right? That would be our variable in the next game. We don't know this next game. To get an average of 13. What is that trying to ask us? It's trying to say that if I add all of these points, right, that I score in a game plus X, so I need to add the 10 plus the 14 plus, I need to add all of these up, and I need that average to equal 13 points. Okay? So we want to know how many points they have to score in this game. And if I want an average of 13, look, I only have 18 that's higher at 14. I'm probably going to have to score way more than 11 or 14 points, right? I'm going to have to score more than 13 in that game. So you're going to add all of these numbers here and divide by how many games? 5. This is 5 games, so you're going to divide it by 6, right? When you solve this problem, you should get a number when you add all of these together. When you add all of these first games, plus X divided by 6 equals 13. This is a very basic equation, goes back to how you get rid of the denominator. The next game that you're trying to figure out.
You're good at this.
So,